Hi everyone, Andrew Chubb here from Awalé Resources. Just a quick webinar on Charger. We just put out some fantastic results today, which was 14.7 grams per tonne over 59 metres, which is pretty spectacular, and really nice follow-up to previous results in drill hole number DD88 and the original very high-grade hole in DD83. So without further ado, we'll move on. Forward-looking statements. I'll put this here because there are. We've come up with a new model for mineralization, and I'm going to talk a little bit about that new model, what that means, and how we think it's got potential to build volumes at Charger. So we've got some consistent, very high-grade mineralization. Now we just need to build that out into something meaningful, and we've definitely got scale potential at Charger, which I think we've been people have been not understanding, and that's probably through I guess me not talking about enough of this in 3D and the difficulty of displaying these something like Charger in 2D cross sections and so forth. So quick recap, we're at Charger. It's in the joint venture permits here, just here, the Charger discovery, and the Charger and BBM are where we've formed a focus of our drilling for most of this year, but we do have multiple other targets within the joint venture, and we're just venturing out into our 100% Awale permits as well, and where this is called the Cienso permit. Our news release called it Cienso, but we're giving it its own name now. So that is now called the Fremen target, and that sits in 100% Awale properties. Plus, we have multiple other. If you come on and zoom in on this joint venture permit, there are multiple other pipeline targets as well. But we have Empire, Charger, BBM, Lando, and Scepter, which are the ones we tend to talk about the most. So a quick recap on where we are. We did say in the news release that we have the best drill interceptions in Africa in the last year. There's really only two of us. One result there from Resolute at the Syama mine in Mali, but the others, Sambrado from Burkina Faso, West African Resources, and again that's brownfields drilling on a mine site. So that's stepping down dip plunge from what they're currently mining. But we have these three fantastic intercepts from exploration drilling at Charger, which is particularly encouraging from that perspective to be getting these early, very high grade intercepts. And the average grade between all three of those is actually 20 grams per tonne. And that'll come into play when we talk about, how do we build ounces and volume. So just drilling down a bit more on Charger now. Map on the right there is something that if you followed us, you would have seen this quite often. It's a plan view showing the drilling or the drill hole collars at surface, the host Monza diorite here, a northeast shear zone, which is a bit of a bounding structure, but we think it goes from subvertical to more shallow dip out to the northwest. So we think there could be potential underneath there, and that northeast shear zone could be part of this northeast structural control that we're starting to talk about of mineralization. So the map here on the left is again a plan view. It's looking down, but it's giving you the 3D flavor. So you can see the drill hole traces projected to surface really, if you like, and these are the red zones are where we've intercepted breccia in these drill holes. So you can see here that we've got up to close to 200 meters of breccia mineralization that we've intercepted to date, and it's actually more than 200 meters when you measure from higher up here and then going deeper down to where we've actually intercepted this breccia in drill hole number 99, which is from 330 meters down hole. So we've intercepted the breccia body over quite a large distance now. The grades can be spectacular, and we've demonstrated the repeatability of those spectacular grades. And you know, the most recent drill program has brought in a new idea in a fold model. The fold model explains a lot of the drilling that we've done to date, and we're getting very high grade mineralization within fold hinges. So we'll keep talking about, or just drilling down that a little bit more, and just trying to explain that to you. And getting the three-dimensional idea of fold hinges across is not the easiest thing. So, and I'll try and keep it as simple as possible. So this slide here, I've kept that same plan view on the left, and then on the other side is this cross section, which is showing what the fold looks like in cross section. Now, what's the cross section? The cross section goes down along 83 to drill hole 100. So we've cut a line straight through 83 to 100, and we're now looking through that to the west-northwest. Okay, so we're looking at these two drill holes here in cross section, looking to the west-northwest, and you can see that where we're interpreting a very tight fold, and there is thickening in that fold hinge, and then we get more attenuated limbs, and there is particular evidence for that in the drill core. And one key thing to take away from this is that when we have a look at a long section on the long section on the next slide, you will see this drill hole here, number 87, which we reported in a previous release. It has no significant mineralization. And another step across, drill hole 86, which comes across to the east here, I think that's the hole here, it has no significant mineralization. And it also didn't display the structural detail or the structures that we were seeing in drill holes which were further to the east. And this led us down the path of revisiting all the core, looking at it, trying to understand what that actually meant, and then coming to the realization that what we thought was previously quite a lot of disorder in the breccia, that there is actually order in the breccia, and that is can be explained with a fold model. So this is that next slide. We're talking about keeping that plan view here on the left, and instead of cutting a cross section through like this, we are actually looking on the right hand side at a long section which travels all the way along toward the northeast through all that breccia mineralization. So now we're looking in this direction towards the northwest through that mineralization, and here are those holes 86 and 87 that I was talking about, which, you know, no mineralization and none of the structural features that we recognized. We saw alteration that we recognized, but not the structural features that we recognized in drill core from here. And then, you know, as there's more slides that start to build on that folding evidence. And the other key one down here is hole 99. So we've intercepted breccia at depth. Now it doesn't have shoot the lights out mineralization, but the breccia is mineralized, and we think, you know, definitely fits into the story that we've got, and the opportunity to build more high grade intercepts at Charger based on the fold model. And it's just telling us that the brecciation or the breccia bodies are open at depth, and we expect them to continue down at depth. And we also now, with this fold model, you know, there could be a parallel corridor or a parallel mineralized corridor down to the southeast as well. And we are actually also open as we move to the northeast with the fold model, because 86 and 87, these guys which weren't mineralized, they just have not hit the folds as they are oriented, and I guess that's something that's difficult to visualize in 3 dimensions, but only, you know, generally only quite experienced geologists are able to visualize things like this. So, but I'll do my best to try and explain to you how this looks. This is just, you know, a slide showing the evidence that was started to build on site. fantastic job being done on the core and making order of what we thought was quite disordered. And so the table there basically is dividing what we the gold grades that we get in those thickened hinge zones in drill hole 83, 85, 88 and 100, and then grades that we have interpreted to be in hinge zones where it flattens out and it's attenuated. So you can see that generally, 85 is, you always get internal grade variability in high grade gold systems as well, which adds sort of a little bit of complexity to it as well. But the holes that we've been talking about, 26 grams per ton, 20 average grade, this is over those intervals, 56 at 26, 29 at 20, and 59 at 14.7. So these, going back to what I talked about before, this average gold grade in those zones, 20 grams per ton. The gram meters, when you multiply grams by meters, it's huge. We've got an average of 735 gram meters, through those interpreted hinge zones. When you get out in the limbs, we've got an average of 30 gram meters, but there's quite a few holes that range at above 50 gram meters, and as mentioned before, and up to 100 gram meters. And if you add multiple limbs where drill holes have drilled through interpreted to drill through a couple of limbs now, they're 100 gram meter holes. So, it's still quite high, like nice mineralization by anyone's standard in those limb zones, but it is really these hinges that are the prize. And so here is a cartoon showing the attenuated limbs and the thickening in a hinge zone. So you get this thickening in these hinge zones in these tight folds. And this picture down here is an example from the drill core where we've got thickening and attenuation in a limb and a hinge of a centimetre scale fold. So just moving in, so what does all that mean? Just a quick recap, I've just talked about it again. What we mean is we don't need a significant amount of volume if we can connect hinge zones together to create lots of ounces of gold. So if you imagine a hinge zone let's say it's as a cylinder, and if you imagine it like a cylinder, or the inside of a toilet roll, or whatever you want to call it, that cylindrical would follow along the fold hinge, and if that cylinder was 50 meters in diameter and 100 meters long and running 15, let's say, even discount that a bit, 15 grams per ton, you would have 250,000 ounces in that one fold hinge over 100 meters. So you don't need to move far to build ounces. And that, these are conceptual exploration targets. Okay, this is conceptual exploration targets that I'm talking about. And so this is just what I'm going to do is I've arranged some sections that are aligned. Okay, so there is a reference line, and this 300 meter RL is aligned as we step through the sections, and so this is one fold hinge. This is another potential fold hinge, and another potential fold hinge, and another potential fold hinge in that fold sort of train. And then this is out here. It's just depicting that potential parallel corridor. But if I put the laser marker there and step through, you can see the fold hinge moving in the sections that we've got, and each one of these sections is 25 meters apart. So we can see we've moved across, that same fold hinge moved across to the left. So that first one was the section through drill hole 100 and drill hole 83. Now we've moved across 25 to 30 meters, and we've got drill hole number 88 and 85, fold hinge, and then now we're getting into exploration targets. So these are holes 132 and 131 and 45, which were all nicely mineralized. If you look back through results, and so 132 we were interpreting as another different fold hinge, and then blue sky out here, where we, as a target zone, which is the continuation of the mineralization in drill holes 100, 83 and 88. So this is where it's stepping across again. And so these are really sort of interesting. You know, this is where that potential comes, and like I said, all through this zone, with the limited amount of drilling we've done, we have intercepted breccia. So the next drilling that we do at Charger toward the end of this quarter and into the first quarter of next year, we'll be testing this fold model, and we really hope to see that we start to build some volume around those high grades. So this is just the final slide, showing some photos of the drill core, and you know, it's really pretty drill core and really interesting stuff, and it's really exciting that we're coming out with this new fold model, and where we hope that we can, you know, repeat, where we think we can repeat these spectacularly consistent high-grade results that we've seen in this one particular fold hinge with drill holes 188 and 83. And so it's really exciting stuff for us. We do believe that there's volume potential. We don't need to move far to create volume with high numbers of ounces at these kind of grades. Even if we you know, go back to conservative estimates at 10 to 15 grams per ton rather than the current weighted average grade of 20. So, you know, we're really excited for the next phase of drilling, where we can test this fold model, and, you know, I think we'll put some work in and try and put it into 3D. And the next time I'll talk to you, maybe I'll be able to show you some of those fold hinges in 3 dimensions, with the ones that we've actually drilled and the other ones which we're looking at as you know, exploration targets, as other hinges within that mineralized corridor. So thanks very much for your time, everyone. I hope that explained a little bit about where we are and what Charger is really all about, and the fact that Charger really does have volume potential. And we haven't been drilling directed specials. We've been drilling holes to try and understand the geometry of the system and build it out and make Charger something, you know, real and mineable. Thanks very much.